Continuing the notes on section 8.3, now we're going to look at if I give you a couple of the components and I ask you to figure out what the equation of the hyperbola looks like. If you've already written down some of the formulas and the rules for the graphs, you don't need to write those again. I just have them in here for reference. It'll be more important to copy down the examples. Okay, so here on the first example we're going to look at, they've given us two of the coordinates of the foci, and we want to remember that the foci determines the length of C. So since I have the coordinates at 0, 3 and 0, -3, then I know that the length of C has to be equal to 3. It's going 3 up or 3 down. They've also given us the transverse axis length, and they told us that it's 4. Now the transverse axis length is 2a, so that means a equals 2. So we have two of our values of the a, b, and c numbers. We could also go ahead and label the h and the k right now if we needed to. The center is always halfway between the coordinates. So since they gave us the coordinate 0, 3 and the coordinate 0, -3, halfway between those two, the center would be the origin, 0, 0. Now for the last number, the problem is we need to know what b equals. As long as you know two of the three numbers, a, b, and c, then you should be able to use this formula right here to find the missing number. So in this case, I'm going to be plugging in that I know c squared and a squared, and I'm going to solve for b squared. So c squared equals a squared plus b squared. If you subtract the 4 from both sides of the equation, now I know that b squared equals 5. You don't even actually have to identify that b equals the square root of 5. That's okay, it's not needed, because again, when we're looking at the equations, the formula uses b squared anyways. So it doesn't really make sense to take the square root and then square it again right after. It's just unnecessary work. So we do want to look at whether this shape is going up and down or left and right. So by looking at the foci here, we can see that one of them goes up 3 units and the other one goes down 3 units. And the foci will go in the same direction as the transverse axis. So I know that since it's going up and down, it can't be this case. It has to be this case. The foci are on top of each other. Those little points that are kind of protected by the parabolas. So it's got to be the case where y squared is coming first. So I'm going to have y minus k squared over a squared, and then x minus h squared over b squared. Since our h and k values were 0, we can actually just write y squared, and then there's an x squared, and it's always set equal to 1. The other important thing to remind you, when we're doing the ellipse, it has a plus in between, but now it's a minus sign. So don't make a mistake on the signs for this. This is a hyperbola, so I have to put that it's a minus. And then we said a squared is going on the first denominator, so that's going to be 4, and b squared is going in the second denominator, so that's 5. For a second example, this time instead of giving us the transverse axis length directly, they've just told us what the transverse axis endpoints are, so the coordinates at the ends of the transverse axis. So we should be able to find the length of A from this anyways. What I'm going to pay attention to is the x values are not changing, so I'm just going to ignore those for a second. And what I notice is that the y coordinates from -9 to -2, that length is 7. So I know that 2a equals 7, which means a equals 7/2. I'm going to go ahead and do the same thing to find the c value. So I have foci of -3. Those are the same. They didn't change, so I'm going to ignore those. But if I look at the y coordinates, it goes from -11 to 0. So that means the 2c value is equal to 11. So c equals 11/2. So the next part will be a little ugly just since I got fraction numbers for a and c, which we don't do very often. But I'm still going to use the approach we did in the last one, where c squared, it's 121, equals a squared plus b squared. Now, luckily, these have a common denominator at least. So when you subtract the 49 from both sides, you don't have to worry about getting a common denominator. It's already done. And 72 is a number that's divisible by 4, so we can actually reduce that fraction, or if you just cut it in half first and then do it as two different steps, that would be fine as well. So you could break that down as 36 over 2, which is then equal to 18. And remember, we don't need to actually solve for b. I can just stop by saying b squared equals 18. So we should have enough information to fill in our graph. Now on this one, the foci or the transverse axis points, either way, you can see that the x values aren't changing. It's going up and down for the transverse axis and for the foci, which means that it must be the up and down hyperbola case again. So I'm going to do the one that starts off with y squared. And this one's not centered at the origin, so I am going to have a number being subtracted from the x and the y values. We didn't talk about that number earlier. We can find it real quick though. So whether you go from the transverse axis or the foci endpoints doesn't really matter. We want the point that's halfway between. So the x value doesn't change, which means the midpoint is still going to be at -3. So I put +3 for the equation. And then halfway between 0 and -11 would be -5.5. And so I'll just go ahead and put that in the decimal form, plus 5.5 for the y coordinate. That's what's halfway between 0 and 11. And then in the denominator, our a squared number, since a is equal to 7/2. In fact, it might even be better to do this one as a decimal, because then you don't have to worry about having fractions inside of fractions. So I'm just going to take the 3/2 value and square that and leave that as a decimal instead. So that'll be 12.25 for a squared. And b squared came out to a whole number, so that would be 18. So it was an uglier hyperbola than a lot of the other ones we looked at. And if something like that does happen, you can certainly switch to decimal form if you'd rather. So even in the beginning, we could have said that that was 3.5 and that this number was 5.5. That would have been okay. For the last example here, we're again going to go through that process of proving that the shape is a hyperbola. Right now, you probably can't tell just by looking at the equation, so you want to go through that process of grouping together the x's, leave a blank space, group together the y's, leave a blank space, and put the constant on the other side. Now on the left-hand piece, that's already set up for us to complete the square, it's fine. But for the y's, I have to factor out that -4 because you cannot have that number in front right here. So I'm going to have to factor out -4 from all of the y terms, but nothing else. So the left piece I'm going to leave alone. And then I'm going to write -4, which will make this positive y squared minus 6y in the parentheses. And then for completing the square, you take half of that middle number, which is -5, and if you square it, that would be 25. And then when you do the same thing for the y's, half of -6 is -3, squared is +9. But don't forget that I'm actually doing 9 times -4. Because of that -4 I factored out earlier, 9 times -4 is -36. That's what I need to add to the other side. And then the factoring will always break down nicely. The x piece, it should be half of the middle number. And for the y's, half of the middle number. And then if you add together the 15 plus 25 is 40, minus 36 is +4, but I can't have a 4 over there. I need to divide everything by 4 in this case. So that'll leave me with x minus 5 squared over 4 minus y minus 3 squared over 1, technically, I'm going to go ahead and write just so it matches our form better. What happened is when I divide by 4, the 4 in the numerator and the 4 in the denominator would cancel. So the 4 over 4 just makes it over 1. Usually I hate writing something over 1, but I just wanted you to see how this matches the hyperbola form. So if I were writing this, I really wouldn't want to have that fraction bar there and say divided by 1. I'm just doing that for a second to make it easier for you guys to see what shape this is. So now you can see that I have my x minus h squared, my y minus k squared. I'm dividing by a squared and b squared, and I have set equal to 1. And it's a hyperbola, not an ellipse, because of the minus sign there. So if I had to graph this one, we know that the center goes right 5 and up 3. And then the a value, it goes to the right 2 and to the left 2. That's coming from the number underneath x. So if a squared equals 4, then a says go left 2 and right 2. And then for the y value, that's telling me to go up 1 and down 1. So that gives me the rough shape of a rectangle. And then I can draw in the asymptotes going through the diagonals of this. And since this is a hyperbola that starts with an x, that means it's the case where it's going to the left and to the right instead. So I would sketch my graph on the left-hand side and the right-hand side, which kind of goes off the graph right there. So that's how we've proved that we do in fact have a hyperbola. And now that I've gotten rid of that other stuff, I'm going to go ahead and go back to erasing that piece. So it just looks like this. In general, you never have to show me multiplying by 1, dividing by 1. You also don't have to show me adding or subtracting 0. It's just unnecessary, and we don't like writing that in math. So that's all for the notes today. Thank you.